All right, we're going to move into 7.5, which is solving exponents and log equations. There are three sections of these. We're going to break them up into 3 different days. So today we are going to do the getting the same base. When you see these equations, they're going to have bases and exponents to each other. And what you need to do is you need to make the bases the same so that you can solve for the exponents. So this is the one case where log won't be used because there isn't a log in the problem. So what you're going to do is you're going to look at these bases and you're going to see which base they have in common. And of course, using 27 and 3, they are both 3. So 3 to the 2x and something, 3 to the something is 27. Well, we have seen this enough that it's 3 to the third. So to solve this, what we're going to do is we're going to distribute this 3 to this exponent of the original. So to rewrite it, you're going to have 3 to the 2x equals 3 to the 3x plus 3. Don't forget that distributing. Now, what's kind of cool about this, and I know that I use that term loosely, is that if the bases are the same, they're actually going to cancel out. And we can use just the exponents to solve for the x. So when we solve and we subtract the 3x to both sides, and we get negative x equals 3 or x equals negative 3, we have our answer. So to check this, if you wanted to check this over and to make sure you did it right, you put negative 3 into the x's and put them in the calculator and see if they're right. So let's go do that. 3 to the, and 2 times negative 3. Oh, I'm sorry. I think I just forgot what the answer was. Okay. And then 27 to the, see now I forget everything I look at. X plus 1. And you get negative 3 plus 1. You see that the decimals are the same. So you know you got that right. So let's try this one over here. We'll go in red. So this here, this is a 2, and this is a 16. So again, pretty obvious that this one will be base 2. So 2 to the something is 16, right? So 2 to the what is 16? 2 to the 4th is 16. 2 squared is 4. 2 to the third is 8. 2 to the 4th. So again, we are going to distribute. Don't forget that. That's the big one now. That's the thing that everyone messes up on, is the distributing part. So we're going to go 2 to the 4x plus 12. And again, you don't have to, you just do it. You don't have to cross it out. But you can now, wrong color, now you can just say x minus 1 equals 4x plus 12. We'll minus the x here, and we'll subtract the 12. So we're going to minus x here, subtract the 12 there, and hopefully you followed me on that you're going to get negative 13 equals 3x. And so you're actually going to get a fraction on this one of negative 13. I changed my colors here. Negative 13. Negative. Oh, I did mess that up. I knew I did that mess it up here. I'm sorry. I'm sorry about that. Here we go. Try this again. Divide by 3, and you get. Sorry, guys. Trying to hit these buttons, and I'm trying to change my color to red. Here we go. So then your x is going to be negative 13 over 3. Again, I am really sorry about this. Messiness. Messy. Okay, sorry. Negative 13 over 3 is your answer for that one. Okay, let's move on. All right, so here we are. Now these get interesting. Sorry, give me a sec. Sorry about this, guys. I should have done this a little earlier. I'm going to move this down a little bit. There you go. Sorry about that. All right. So here you notice that you have these two bases and they're 4. Well, 4 is the smallest one, but 4 doesn't raise to 8. 4 squared is 16. So the common base between 4 and 8 is 2. So 2 squared to the 3x and 2 to the third to the x plus 1. So it can get a little tricky there, but this is going to be 2 to the 6x after distributing and 2 to the 3x plus 3 after distributing. So again, you drop the bases, you get 6x equals 3x plus 3, or 3x equals 3, or simply x equals 1. So that worked out nicely. But just be careful, when you have these bases, they're not going to be the same, just like this one here. This one here is a 32 and an 8. 8 doesn't become 32 at any point. 8 squared is 64. So the bases that are the same are 2. So 2 to the 5th is 32, and 2 to the 3rd is 8, and we distribute just this side here, guys. Just that. Leave that alone. So we get 2 to the 5th equals 2 to the 3x minus 3, or 5 equals 3x minus 3. Add the 3 to both sides. You get 3x equals 8, or x equals 8 thirds. And again, I've showed you how to check it. Put 8 thirds right into that x, and if you get 8 to the 8 thirds minus 1, you'll get 32. All right, so we move on to example 5 and 6. Now this is a little, again, I'm sorry, let me do this real quick. Let's do this real quick. Move this down a little bit so you can see as I'm writing. Sorry about this, guys. I should have done this earlier, but I didn't. All right. So here, before you can sit there and change the base on this particular one, you have to get rid of all the stuff that is around it. All right. So we're going to do that first, and then what you're going to have is just bases. That's what you're looking for. You're just looking for bases. So we'll start by subtracting 2. You get negative 1/3, 3 to the 2x equals negative 9. And now here you're going to multiply by negative 3. That's how you get rid of the fraction. And you get 3 to the 2x equals 27. Now 3 is a good base. It's a prime base, and 27 is raised. Sorry about that. To 3 to the third. So this is simple. 2x equals 3, or x equals 3 halves. That's it. That one's done. So take care of everything else first, as I will do again here, is I'm going to add the 7 first. You get 3 times 2 to the 4x equals 24. And then I'm going to divide 3 here. Don't multiply those, guys. That's a bad thing. Don't multiply them. All right, so 2 to the 4x equals 8. And we have done this, I think, 3 times already. That 8 is 2 to the third. So you get 4x equals 3. And divide by 4, you get 3/4. Okay? So it's pretty basic once you get used to it, but you got to get used to it. Now, the nice thing about recording these is you can go back and look at these again, look at the way I did each problem. They are different in kind of different ways. These were simple bases to convert. These you had to see which ones they were. They were both 2s, but they could be, a 27 and an 81, and you have to convert those to 3s. And then these here, you had to do some algebra before it. So here's your steps. So if we were taking notes in class, these are the steps that you could do. So to rewrite each power so that they have the same base, use the power property. So what you're really doing is distributing in time, but you're multiplying. And then you're just going to make the exponents the same and solve. So here's the steps you're going to do. So you can pause it and do the work by looking at these steps. Continue to look at the examples. So it's a worksheet this time. I think it's a worksheet for the next couple times. And those will be attached in Teams. All righty. Take care.